And it's going to go over transformations of functions. So what we're going to be doing today is we're going to be just really moving functions up, down, left, right, and then reflecting them around axes. And it's kind of weird, but it's not too bad. Let me get this going. Okay, we're good there. Okay, sweet. We're good to go. Click on that to go away. You guys can see that? Not bad? Okay, good. Okay, so first off, are there any questions from 2.4 homework? Yes, or 2.3? They're kind of the same, that linear function stuff. Let me get in the, have the chat kind of open here. Like, that's okay, right? Okay, all right. Okay. If you guys see something pop up in the chat, it's hard for me to notice it when I'm talking. Let me know. Okay. Okay, let's get started on 2.5. Now, I'm going to tell you, first off, your book kind of focuses on these, they call them common functions, graphs of common functions. There's 7 at the very beginning of section 2.5. I refer to these as parent functions because the first book I taught out of called them parent functions. And we're going to get to that eventually. I kind of don't like the way your book orders this section. So I go on it in my own order, but we cover all the content. So before we talk about the common functions, which I'll bring in here in a minute, we're going to talk about the transformations, and I'll bring the common functions into explaining these transformations. Okay, so again, a transformation is just a function that's going to move. It's going to move up, down, left, right, flip, do things like this. Now, the only transformation we're not going to talk about is stretching and shrinking. That's a non-rigid transformation, and it's going to, you'll see, we're just not going over that. I don't think it's that important to this class and to the college algebra curriculum. So we stick to rigid transformations. Rigid transformations. Okay, we're going to stick to rigid transformations. And the very first rigid transformation we're going to talk about is the vertical shift. Okay, and to talk about the vertical shift, the first thing I'm going to do is actually draw just a line. Okay, and it's going to be a function, but it's just going to be a straight line. I'm going to use it a few different ways, so I'm going to try to get as much out of this one graph as I can. 2, 3, 4, 6, 4, 5, 6. Let's just go up and down 6 will probably be enough. Okay, and we're going to call this function, let's just shift it to the camera. We're going to call this function f of x, and it goes from, let's say, negative 3, positive 1. So negative 3, positive 1. And then it goes over to, let's say, positive 2, positive 3. Why not? It doesn't really matter. It's just a straight line that goes between those two coordinates. Okay? And we're going to call that guy f of x. And that's going to be our original function. What we're going to do over the next few examples, we're going to move this thing up, down, left, right. I'm going to kind of show you how to do it. Actually, hopefully I do show you how to do it. So for a vertical shift, either up or down, it's kind of easy. What you're doing is you're keeping the x values the exact same, and all you're doing is moving the y values up and down. Okay, very straightforward. So if I had, let's say, if I wanted to move, let's say up first, up, and we'll say c units. If I wanted to move up c units, all I would have to do is add c to the outside of the function. Okay, all I would have to do is add c to the outside of the function. So let's use a blue marker, and we're going to call g of x. So we're going to shift f of x up, let's do 3 units. Shift f of x up 3 units, and then we're going to call it g of x. Okay, we're going to call it g of x. So we're going to shift, there's 9 there, so it's hard to see. Shift f of x up 3 units and call it g of x. So our g of x function is just f of x plus 3. Okay, now graphically what that means is we're going to take this function, we're going to go up 3 units. So let's see, this coordinate's just going to go up 3 units. So 1, 2, 3, it'll be right there. And then this coordinate's going to go up 3 units. So 1, 2, 3. It would be right there. Now it's going to run parallel because it's supposed to be parallel. That's just the human nature in me. It's not looking parallel. But all it is this function shifted up 3 units. So it's g of x. Okay? That's our g of x. And all we have to do, now this is what's important, that plus 3 is on the outside of the function, not the inside. Okay? The inside's going to move it left or right. We'll get to that in a minute. Okay? But the plus 3 being on the outside is going to go up or down. So if we want to go down c units, all you have to do is subtract c from the outside. Okay? So let's do this one in red. So say we wanted to take our f of x, remember our original f of x here, and we want to shift f of x down, let's just do 2 units. And we'll call it h of x, okay? We're going to shift f of x down 2 units, and we're just going to call it h of x. The way this would look actually is h of x equals f of x. Now we're going down, so we have to have subtraction. Down is subtraction, so minus 2. Okay, so I'm going to take this original f of x graph, and I'm going to go down 1, 2. That's really right here, so 1, 2 about right there. And then I've got my h of x, okay? So to go up, you add on the outside. To go down, you subtract on the outside of the function. It's not too crazy. Okay, it's not crazy at all, actually. So now let's look at, I'm going to bring in a parent function now, and we're going to do that to the parent function just to see what it looks like with an equation. Now, I might come back to this graph. So I'm going to save it over here. Let's say our parent function, and I'm going to go back. This is at the beginning of section 2.5. I'm going to say f of x equals, let's start with the absolute value. Why not? The absolute value of x. Okay? So the first thing I'm going to do is actually graph this so we can get kind of comfortable seeing what the absolute value graph looks like. The absolute value graph, if I wanted to graph it, it looks like a V, and you can see it in the book there, but it hits the origin. And then think about this. If I plug in a positive 1 to that function, positive 1x, I would get back an absolute value of 1. So I get back a positive 1x, or positive 1. If I put in positive 2, I would get back positive 2. And then this is actually going to be even symmetry. It's going to be symmetric around the y-axis. So if I put in negative 1, we know the absolute value of negative 1 is a positive 1, right? Because it's the distance from 0. And then negative 2, same exact thing. Negative 2, we get back a positive 2. So the original function, or the parent function, looks like this. That is f of x, okay? Nothing crazy. And you'll see in the book, in the homework, the first step is going to be graph the parent function, okay? And you'll just need to do that. So graph the parent function. So let's say for this example, we want to find, we'll use different letters. It doesn't, we already use G and H, right? Let's use J. Find J of x, which is f of x, shifted, let's go down. Down, let's say 2 units. Okay? Let's see. Let me might take a break and get some more colors here in a second. But let's use red now. So if I was going to shift this down, all we have to do is subtract 2. But here's what's important, and this is why I'm bringing it up with the actual functions. We have to shift 2 on the outside of this parent function, okay? So we have to do the minus 2 on the outside, not the inside of the absolute value, but the outside. So J of x would look like this. It's going to be the absolute value of x, then minus 2, right? Because remember, this is our original function. This is f of x, right? That's what we started with. So if we want to go down, we have to do subtract 2. So now on the graph, all it looks like is, now I'm going to kind of just choose points and then shift them down. So The origin point, if I shifted it down to, it would be here. This point would be right there. This point would be right here, and boom. We've got our j of x. Okay? Kind of neat. Now, but look, so when we're dealing with actual functions, like with actual equations, instead of writing it as, f of x minus 2, you actually put in what the function is. It's the absolute value of x, right? The absolute value of x minus 2. Okay? Questions about that? Makes sense. It's not bad. All right. I'm going to come back to this one because I'm going to do the horizontal shifting on it. So I'll be back to this one here in a second, but let's talk about horizontal shifting now. I'm not horizontal, I'm sorry. No, I'm right. Horizontal shifting. So we talked about vertical, that's up or down, and really it's subtraction or minus on the outside. Well, for horizontal, you have to do the addition or subtraction on the inside of the function. So for horizontal shifting, now look, this is a little weirder because it's going to be backwards with the logic, okay? If I want, let's go to the right first. So if I want to go right C units, okay? So if I want to go to the right C units, I actually have to subtract inside the function, okay? I have to subtract inside the function. So let's draw a little line again. Actually, I might do one that looks like your homework. Hold on. They've got kind of an easy one. I say easy. I haven't just an easy graph. Ugh, I don't like the graphs. They're a little more complex than I want to draw, except for one of them. Okay, so let's do the same kind of thing from before. We'll make up some other one. Let's say we had a graph. Now we're going to go left to right here. Remember, it has to be a function. Let's say we have a graph that starts at like -1, 1, but then it's a lot more steep. So let's say it goes 1, 1, 2, 3, 4, 1, 4. Okay. So again, it's just a line. It's just a basic graph. Nothing crazy. But now we're going to move it left to right. And let's make up a function again. Let's say c of x here. Okay, c of x is f of x shifted. Now we're going to go to the right. Right 3 units. Okay, we're going to go to the right 3 units with our c of x. So if I'm going to write this c of x out, it's going to be the original function, but instead of the subtraction of x being on the outside, it's going to be on the inside. So it looks like this, x minus 3, okay? And that's going to move this original function to the right 3 units. Very straightforward, okay? Not too crazy. I know, it's exhilarating, but it's not too crazy. So let's do this. So I'm going to move this to the right 3 units. 1, 2, 3, boom. I wind up there, okay? And then up here, I'm going to move it to the right 3 units. So 1, 2, 3, it's about right there. Boom, we've got our c of x. That's our c of x, okay? It's like f of x here. That's our f of x, right? Okay, now to go to the left though is the opposite, right? So really kind of if you kind of have one memorized, the other one's vice versa, right? So if I want to go to the left, you guessed it, I've got to add inside. Okay, you just add c units. So let's say I want to do that same thing, but we'll do L of x. L of x is f of x shifted left. Let's just go 1 unit. Okay, just f of x shifted left 1 unit. So L of x would be f of x plus 1. Okay, and I know it's backwards. The reasoning behind that is it's kind of easier to see with the equations, but it's really the distance to get back to the original coordinate. And I know that sounds goofy. We'll see it here with this one. So if I take my f of x and I go to the left 1 unit, it looks something like this, right? That's L of x, okay? So that x value has to get us back to the original coordinate. Now look, to get back to this original coordinate, I'd have to subtract 1 to get back to here, okay? And that's kind of the easiest way to think about it. And I know it's weird. It's weirder with the horizontal shifting, but that gets us back to where we need to be. Okay. Questions? It's not bad. It really isn't. We're going to combine both of these here in a second. But it's really not bad. I think this section's not bad. It's just a lot of new stuff. So I'm going to go back to this graph. Okay. Back to the absolute value graph. And now instead of a vertical, I'm going to do a horizontal shifting. Done. Let's say we've got, what's the letter I haven't used? M. Fine. Find m of x, which is f of x shifted. Let's go to the left so I don't run into the stuff I've written over here. Shifted left. Let's do 3 units. So find m of x, which is just f of x, shifted to the left 3 units. So I need another line there. Blue sounds good. So we've got m of x. Now remember, for this one though, instead of I'm going to the left, so I've got to add. No, that's goofy, but we're going to add 3. But instead of the addition being on the outside, it's got to be on the inside of the function. So it's going to be x plus 3 on the inside of that absolute value. Okay? It's on the inside. So that's what we have to recognize. When we see like this function, I need you to notice that plus 3 is on the inside, so it's a horizontal shifting. And when you see this function, you've got a minus 2 on the outside, so I need you to realize this is a vertical shifting. Okay? That's the indicator. So m of x is just the absolute value of x plus 3, and all this does is it shifts over 3 units. All these shift over 3 units. So this one's going to be 1, 2, 3. This unit here is going to be actually 1, 2, 3, and you wind up with the same exact graph, right? Same exact graph, just shifted over 3 units. And now notice. Now remember, I called these rigid transformations. The reason they're called rigid is because it's the same exact shape, just moved down, left, or eventually we're going to get down and left, down and right, all that fun stuff. Okay, we're going to combine these actually on the next example. But just realize that's what rigid means. The non-rigid, which we're not going over, really it stretches it, or it's, this way, or it shrinks it in. That's a non-rigid transformation. Okay. Questions? Making sense on Zoom there, guys? Give me a thumbs up if you're following along right now. Hey, a physical thumbs up, that worked too. Awesome. Okay, so let's combine these. And now when you combine them though, this is, you have to do it in a specific order. And I'm going to tell you, it doesn't really matter with just horizontal and vertical shifting, but we've got to go over it. And in the book, it's kind of towards the end of this section. It's on page 280 in this edition. But if you're going to combine, horizontal, vertical, stretching and shrinking, which we're not going to talk about, we will do reflecting. You have to do them in a certain order. And the order looks like this. First, you've got to do horizontal shifting. Then second, you're going to do stretching and shrinking. Now, we're not going to go over that, so you don't have to worry about step 2. Stretching / shrinking. And then third, reflecting. Now we are going to go over that. That'll be the next topic here in a minute, once we get the horizontal and vertical down. And then last, you're going to do vertical. Okay. So for now, we're just going to be worried about these two. So we're going to do the horizontal shifting first, and then we're going to do the vertical shifting. So let's look at one that has both. So I'm going to do it with a basic graph first before we go to parent functions. So let's say, actually, you know what? Let's do one out of the homework to kind of show you what I'm talking about. Let's look at number 22. This is number 22 in the book. And the graph is kind of the sideways S. Okay. I'm trying to draw it a little bigger. So we're -4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And it goes up what? 2. 1, 2, 3, 4. 2, 3, 4. Now the original function here is g of x actually. Well, no, it's f of x. It starts at -4, 0. It goes down to -2, 2. It goes to the origin. Then it goes to 2, 2. Then it goes to 4, 0. Okay? So this is what the original function looks like. And they're calling that, f of x. And then in 22, it says, what is the color for it? 22, it says g of x equals f of x plus 1 minus 2. Okay? F of x plus 1 minus 2. So we have multiple shiftings going on here. And that's what I need your brain to kind of notice this as we're doing it. Okay? Now look, here's inside the function, here's outside. So outside the function, that's a vertical shift, right? And since it's a -2 on the outside, it's down 2. But then we've got a +1 on the inside. The +1 on the inside, remember, now this means it's a horizontal shift. It's an alarm. It randomly does that. A horizontal shift. Now the +1, though, remember it's backwards. So instead of going to the right one, I know that's what our brain wants to think, we're going to go to the left one. Left one unit. Okay? So I'm going to do that over here. So now I've got to make 2 shifts. So first I'm going to think of it horizontally. So I'm going to go left 1. And then I'm going to think of it vertically, down 2. So now look, what I'm going to do, really there's 4 kind of key points on this graph. Really, I guess 5 if you count the origin. I'm going to do each one of them. I'm going to do the 4 points, not the origin. So I'm going to start here, and I'm going to go to the left 1, and then I'm going to go down 2. 1, 2. I'd end up right there, right? And then I'm going to do the same thing here. Left 1, down 2. I end up there. Up here, left 1, down 2. Right there. Left 1, down 2. Right there. And then I'm just going to connect the dots. Okay. So we had a combination of shifting for this one because we shifted horizontally and vertically with the same graph. Okay. Horizontally and vertically with the same exact graph. Okay. Questions? Comments, concerns? Make sense? It's not too bad, right? Not too bad. Okay, I'm going to give you a few examples. Actually, let's do one with a parent function, and then I'll give you a few examples, and I want you to try them on your own. So the next parent function we're going to talk about is the quadratic. The standard quadratic. So the standard quadratic is f of x equals x squared. Okay? And if you graph this, I think we've talked about this graph already, but if you graph it, we're an even function, right? Because we got x squared. But if we put in 1, we get back 1. 0, we get 0, goes to the origin. 2, we get back 4. 1, 2. And then it's symmetric around the y-axis, which is nice. You can just plot the other side now, but if you put in -1, you would get back a +1. And -2, you get back a +4. So it looks something like that. That's our f of x, right? Okay, I'm going to give you a few examples with these, and I want you to try them with the shifting. And okay, I'm going to give you a few minutes. Let's do for A. I'm kind of looking in your book how they write it. I want you to find h of x, which is x plus 1 squared minus 3. And then I want you to find z of x, which is x minus 3 squared. Let's do plus 1. Now look, I want you to be careful real fast before we get rocking and rolling. Notice the parent function is x squared because this parentheses is squared, okay? And then we've got inside the function and outside, so inside and outside. So I want you to graph these on your graph right here, however you can kind of change them. And we'll see if we get it right or wrong. It's okay to get it wrong. This is practice. Get it? Make sense? Not a bit. Well, let's see if we got it. Hold on. Okay, so let's do h of x first. I know with h of x, the minus 3 on the outside means I need to go down 3. And then the plus 1 on the inside means I need to go to the left 1. So I'm going to take this graph. Now look, I'll start with this origin point. And I'm going to go to the left 1. Remember, we need to do horizontal first. So left 1 and then down 3. 1, 2, 3. That's where my origin is going to be now. So I'm going to steal this one and go left 1, 2, 3. Left 1, 1, 2, 3. And I've got the same graph, right? It's just down 1. It doesn't have to be perfect. Remember, this is going to be on multiple choice test. So it's going to be, you'll choose the one that looks right. So you don't have to worry about shaping it perfectly like handwritten. So let's do the minus 3 and the plus 1. So a little different. So the plus 1 means we go up 1. And the minus 3 means we go to the right 3. So I'm going to take again my origin. I'm going to go to the right 3. But now I'm going to go up 1 right there. So my origin winds up being right there. And then, I'm just going to be a little lazy. Efficient is the fancy way to say that. Just draw my graph. Okay. So I've got z of x here. And I've got h of x right there. Questions? Make sense? Online? Are we good? Okay. So let's do something a little different then. I'm going to kick it up a notch. Yeah. Let's say I want you to find the equation for something. I'm going to describe it, and I want you to find it. So I like this on the test. So let's say given, let's say q of x has a parent function of f of x equals, let's do like the cube root of x, why not, doesn't matter. Given q of x has a parent function of f of x equals the cube root of x and is shifted, let's say left 2 and down 3. I want you to find q of x. Find q of x. So really write the equation out for q of x. Okay. Write the equation out for q of x. Or try to, attempt it. If you don't get it, that's fine. We're gonna go over it. I won't leave you hanging. But think of like what's got to be on the inside of that radical and what's got to be on the outside of the radical, right? Right? I'll put an X here. And I'm going to do something on the inside because I know I've got shifting left, right? This is my horizontal shifting. So that goes on the inside of the function. So really, for this example, in the radical. Now I go to the left 2. I know my brain wants to say minus, but really it's plus 2 on the inside. That covers my left shifting, okay? Now I've got to go down 3. That's the easier one. On the outside of the radical, I just need a minus 3, okay? On the outside of the radical, I just need a minus 3. Okay? Makes sense now? I mean, it's kind of going to be the first time I ask it. So let me do another one then. Let's say given b of x, one up. So the parent function, I'm going to be a little lazy here, not write as many words. Parent function is f of x equals x cubed. And we're shifted. Let's do the opposite. So let's go right 4 and up 7. Okay. And I want you to find b of x now. Ooh, that one is much stronger. Right. Easy. I mean, I say it's easy. It's not. Sometimes it takes a minute to click, and that's okay if it takes a minute to click. That's why we do homework, right? So let's think though. Now if we're thinking of these in terms of parent functions, I've got something inside this cube, and I've got something on the outside. Now there's always going to be an x, but inside is horizontal shifting, which is right here, right 4 units. Now again, I want to say it's plus, but it's actually minus because it's opposite when it comes to the horizontal shifting, but then I'm going to go up 7, right? So here is my b of x, okay? Not too bad. Man, this is pretty simple so far. I mean, we've kind of combined a lot of topics, right? I mean, we now know how to shift left, right, up, down. We even know how to make the equations based on parent functions when we shift left, right, up, down, right? Which is kind of neat. Okay, so let's look now at reflecting. There's 2 types of reflecting. There's x-axis and y-axis. We're going to talk about x-axis reflecting first. So x-axis reflection It just really we're rotating. That's a good way to think of it. Rotating our function, we'll call it f of x, around the x-axis. Okay, we're going to rotate, not potate. That is a rotate. Rotating our function around the x-axis. So let's look at a basic example and what it means. And all you, okay, first off, equationally, all you have to do is make the y's negative, okay? So you'll just put a negative on the outside of the function. And yes, you guessed it. For y-axis, the negative is going to be on the inside of the function. Okay, but for the negative on the outside, that gives us our x-axis reflection. So if we looked at a, just a regular graph, not a parent function, okay, and let's say we start at negative 1, 1, and we go to 1, 2, 3. We go to 3, 3. Why not? Okay. This is our f of x. Now, if we want to rotate f of x, we'll call it, what do you want to call it? We used a, why not? A of x is this f of x reflected around the x-axis. Okay, so all a of x is negative f of x. Okay, that's all it is. You just pop the negative on the outside of the function. What happens though is that it rotates around. So think of it mirroring around the x-axis. So right here, this is negative 2, 1. Well, instead of up 1, it's going to go down 1 right there. Okay, and then this was 3, 3. Well, instead of up 3, it's going to go down 3. And you'll see these two functions are going to be mirrored around the x-axis. Now, they're two separate functions. It's not one function. It's two separate functions, but they're mirrored around the x-axis. Kind of cool, I know. Okay. Let's look at an example of this based on a parent function. Let's do the square root parent function because it's a really common one that's used, and the graph is pretty common here. So let's say we had f of x equals the square root of x. Okay, let's look and see what this looks like. Now, if we want to graph this, like we know we can't put any negative numbers under this radical, right? We took a test over that. So we have to start at 0. And if you put 0 in, you'd get back 0. So we're at 0, 0. And then I'm just going to choose numbers that have nice square roots. All the other numbers have square roots that are positive. It's just they're not as nice. So if I put in 1, the square root of 1 is just 1, right? And then the next square root would be what, 4? 2, 3, 4. And that would be 2. So it looks something like that. And really, these 3 coordinates are what I'm going to use for shifting, okay? Those 3 coordinates are what I'm going to use to move it around. So let's find d of x. D of x is f of x shifted. Let's go left 1 and then reflected around the x-axis. It's going to go to the left 1 and then it's going to reflect around the x-axis. So let me give you some more digits here. Okay. Now, I'm going to find the equation for this now, kind of like the ones I asked you just a little bit ago. So I'm going to develop this equation. So d of x equals, now let's think about this. If I go left 1, that's horizontal shifting. That means it's got to be inside the function. Left means plus, right? So x plus 1. But then the reflecting around the axis, that puts a negative on the outside of the function. So it's going to be a negative square root of x plus 1. That minus is on the outside. Okay? Now, let's go back a few pieces of paper. And I talked about if you're going to graph these, you've got to follow this order. So horizontal, then reflecting, and then vertical. Now we don't have vertical here, right? We don't have an up or down. It would be just add or subtract on the outside. Didn't ask us to do that. So for here, we're going to do horizontal and then reflect. Okay, horizontal then reflect. So I'm going to move it to the left 1, and then I'm going to reflect it around the x-axis. So now let's follow these 3 coordinates. So if I'm going to use this coordinate here, I need to go to the left once. And now look, if I reflect around this x-axis, I don't go anywhere if I'm on the axis. So this just stays put, okay? That stays put. So for the second coordinate, this 1, 1, I go to the left 1, and then I rotate it around the x-axis. So instead of being up 1, it's down 1. That's that next one. So this coordinate transformed to right there. The 4, 2 coordinate, I go to the left 1. Now I'm up 2, so now I'm going to go down 2. And boom. I've got my graph. This is what d of x. Okay? And notice, I mean, just kind of take a quick check here. This is definitely, this graph shifted to the left once, and then I just reflected it, spun it around the x-axis. Okay, and we have the other, the d of x, the other function we're looking for. Okay, makes sense? Not too bad, but now remember, so if you see a graph that looks like this, that means the parent function is the square root function. Okay, parent function is just a square root function. Questions? Okay, I'm going to come back to this one to do the y-axis for reflection, but let's talk about it first. Okay. I'm going to go back to this slide. I'm going to get a little lazy here. Okay, slide. It's a piece of paper. Let's now talk about y-axis reflection because it's a little different. Y-axis is going to be inside the function. Yes. Y-axis reflection is going to be inside the function. So y would equal f of negative x, which we've done a little bit before, right? That's how we check to see if something was even or odd and all that fun stuff. So for y-axis reflection, which we're just going to take the, now don't worry about the red graph, right? Take this black graph, and we're going to just rotate it around this y-axis. For this graph, it's probably going to make an x looking kind of thing with the original. But let's call it t of x, why not? T of x equals f of negative x, okay? And all that's going to do is reflect us around the y-axis. So I'm going to go back to my original function up here, and I'm going to reflect around this y-axis. So really, there's only 2 coordinates, right? So let's do this coordinate first. Notice it's to the left 2 units. Now I'm going to stay the same height, but I'm going to rotate it around to the positive 2 here. So this coordinate transforms to right there for my t of x, okay? And then the other coordinate, which is over what, 3 up 3, it's going to be still up 3, but now it's going to go to the negative, I need another digit here. It's going to go to negative 3 on the x-axis. So it looks like that. So that's going to be my t of x. Okay, that's my t of x. And notice it's just rotated around the y-axis, and it will meet, if it crosses the y-axis, that's where it's going to meet. It'll meet on the y-axis where it crosses. Okay. Questions, comments, concerns? It's not too bad. This is really the last type of shifting we're going to talk about, the last type of transformation. Okay, let's go back to this square root function, and we're going to make the birds that you used to draw your mom or dad in preschool. So here's what we're going to do next. We're going to say, let's find e of x. Now remember, our parent function is the square root of x, but it's just the square root of negative x. Okay, now I didn't make my graph long enough here. That's fine. So 1, 2, 3, 4. Okay, so all we did here was shift around, I should say reflect around the y-axis, right? The negative's on the inside here. So I know this means all I'm doing is taking the square root of x and reflecting around the y-axis. It's kind of hard. These markers are getting kind of soft. The penmanship's getting worse. Okay, but let's talk about that. So now we're going to take this original f of x function and we're going to reflect it around the y-axis. So the origin stays the same, right? Our reflected back is no different, but the 1, 1 turns into negative 1, 1, right there. And the 4, 2, well, it's going to stay the positive, the same height, but then we're going to go to negative 4, 1, 2, 3, 4, up 2. So right there. So this coordinate transformed to here. And notice, those are the birds you drew your mom for the beach scene that you drew in preschool. Yeah. But anyway, so that's, but the square root function is just around the y-axis, just goes the other way. And I know what you're thinking. You're thinking, but Mr. Sherman, you said that I couldn't put a negative number underneath a square root because it would be imaginary. And you're right, you can't put a negative number. But notice if you put negative numbers into this function, they would turn positive because there's a negative on the outside. Like if we chose negative 4 and we put it in here, it would be negative 4. So it turns into positive 4. The square root of 4 is 2. Okay? Kind of neat stuff. Thrilling, amazing. Questions? So let's kind of combine everything now. We're going to do a lot. I'm going to steal examples from the homework where they just kind of combine all kinds of shifting, reflecting, stretching, blah, 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 blah stuff. But let's introduce some more parent functions, at least the graphs anyway. So let's say we've got f of x equals x cubed. Now, okay? Now the x cubed graph kind of graph it out. Well, I know it's 0 at 0. It's going to be an odd function, so it's symmetric on the origin. At 1, it's 1, but at 2, it's 8. 1, 4, 5, 6, 7. I never draw these things long enough. 8. Okay, so it goes up to like here. And then negative 1, well, negative 1 cubed is negative 1. So it's here. And then negative 2, 1, 2, 3, 4, 5, 6, 7. It's like down here somewhere. And it doesn't have to be perfect. Okay. But it looks something like that. I know that looks like it curls back, but it doesn't. It's still getting just larger to the right. Okay. And if you look in your book at the beginning of 2.5, you'll see a better drawing of the x cubed function. So I'm going to give you a few examples, and I just want you to graph them on top of your graph. Okay. So let's do A is going to be z of x. And it's the parent function is going to be x cubed. Okay, so let's do negative x minus 4 cubed. And then B, we'll do f of x, but a capital F, why not? We'll change it up. Equals negative, now the negative's on the inside, plus 3 squared. Oh, you know what? Hold on. This is going to reflect. That's okay. These might kind of be on top of each other. That's fine. Maybe we'll move it down then. Let's say minus 4. Okay. Try those two. Yeah, try those two. They might be sitting kind of on top of each other, and I apologize for that. It's me just making up examples. Let's start the first one. Now remember, I've got to remember that order. Remember, first we're going to do horizontal, right? Second, I think, was the stretching or shrinking. We don't have to worry about that. Third, though, is reflecting. And then the last is vertical. Okay? So if we look at this first one, I think we only have horizontal and then reflecting, right? This is going to be to the right. This is going to be x-axis, right? Reflection. So I'll do this one in red. So to go to the right 4 and then x-axis reflection. So I'm going to, the origin's not going to matter, right? Because I'm going to go to the right 4 and then it's going to stay put. But then let's do this coordinate right here. So I go to the right 4, 1, 2, 3, 4, but then I reflect it around the x-axis. And then this coordinate here, I'm going to go to the right 4, 1, 2, 3, 4, but then I reflect it up around the x-axis. I can kind of see what I've got going on here. I have this graph going on. Okay. So now let's do the capital F of x. So now this is down 4. This is to the left 3. Now this is a y-axis reflection, which is going to look really similar to x-axis for this one. So first I've got to do the horizontal. So I'm going to choose this coordinate again. First I've got to do the horizontal. So horizontal tells me to go to the left 3, 1, 2, 3. Now I've got to do y-axis reflection. So I'm going to go around this y-axis. So 1, 2, 3. Around the y-axis would put me at positive 3. And then I've got to go down 4. 1, 2, 3, 4. So it puts me about right there. That's a lot. Okay. So let's look at this coordinate right here. So same thing. I've got to go to the left 3. 1, 2, 3. But then I go around the y-axis. So I'm left 2 of the y-axis. So I'm going to be right 2 of the y-axis. And then I go down 4. 1, 2, 3, 4. Okay. And then here, I've got to go left 3. 1, 2, 3. Y-axis reflection. Now look, I'm 1, 2, 3, 4 units to the left. So now I'm going to be 4 units to the right. And then I'm going to go down 4. 1, 2, 3, 4. It actually looks like that. Okay. Kind of crazy. That's math of x. Kind of weird, but that's it. Okay. Questions? You combine them all, it does get kind of weird. But if you follow the steps and follow the order is important. Really, order is important, not necessarily with just horizontal and vertical. Order is important when you include reflecting. That's when order really matters on these graphs. Okay. I'm going to steal another one. Let's say, actually, I'm going to steal number 146 because I like the way this one is asked. This is 146 on page 285. It's in your homework, number 146. It says in exercise 145 through 148, functions f and g are graphed in the same rectangular coordinate system. If g is obtained from f through a sequence of transformations, find an equation for g. Okay, so we're going to find g. So first I'm going to graph f. If you don't have the book, I'm going to show you what this looks like. Okay. So let's see. We've got what looks like an absolute value parent function. Okay, that's our f function. Now g function, though, 1, 2, 3, 4, 5, right? So the g function, which I'll put in blue here, is over 5, 1, 2, 3, 4, 5, and then up 1. And then it's flipped around. So here's our g function. So it wants you to find g of x, okay? I want you to do that. Try that for a second. I'll be right back. where you have to find the formula. Now you know how it shifted left, right, up, down, and you know that it's reflected too. So try that real fast. I'm gonna before I get going here, I'm going to just talk about, oh, before I get going, I'm going to talk about what this graph does. Okay, just write it out. I know that, look, this thing is going to shift to the right 1, 2, 3, 4, 5 units. So 5 units to the right, right? And then I know it's got to go up 1 unit. And then it reflects down. So what that means is that it reflects around the x-axis, right? Okay, so let's do that. So, oh my gosh, back's hurting. So I know if it's reflected around the x-axis, it's got to have a negative on the outside of the graph. Now this is an absolute value, right? So the negative's on the outside. I know it goes to the right 5 units, so it's going to be an x minus 5 on the inside, right? That sends me to the right 5 units. Now I've got the reflection with the minus sign here, and then I got to go up 1 unit, so I got to add the 1. Up 1 unit. Okay, make sense? Not bad. You guys get it? Okay. So for homework, now guys, this is going to be the most chopped up homework I ever give you this entire semester, and it's because I don't do the stretching and shrinking. So just be follow along, and it'll be on the YouTube video too if you don't want to write it down. But it's 1 through 10, and if you want to do the odds and then go back and do the evens if you need more experience, more practice, that's fine. So 1 through 10, and then 17 through 26, and then 33 through 38, 45 through 48, 53 through 60. And guys, this is not that much. It's just I'm breaking it apart, so it looks a lot worse than it really is. 67 through 74, 81 through 90, and then 95 through 100, 107 through 110, and then 145. Now I do want you to do 145 through 147. I like those questions where it hit 146 already. So try those. Now look, it's okay if you just want to do all the odds, and then if you need more practice, that's fine. But it looks like a lot. A lot of these take like 2 seconds, right? I mean, oh, it shifted to the left twice. Done. Okay. So it looks like a lot. It really isn't. You guys have any questions? Not anything? Any questions on Zoom before we get?
What page is that on?
Oh yeah. If you've got the newest edition, it starts on page 282.
Okay, thank you.
Yeah, no problem. And it's on this is section what, 2.5? 2.5. Okay. You guys are free to go. Hey, CJ, did you get the new book?
I did indeed.
You what?
I did.
Sweet.
Came
Awesome.
in today.
Yeah, no problem. Okay, great. So I will see you guys all on Thursday. I'll be on here a little bit if you need any help with anything. I'll stick around because you've got 10 more minutes. You guys are pretty good.